We will be looking at the October 2020 multiple choice questions for the inorganic chemistry paper. Question 1. It says several students titrate 25 centimeters cubed of the same solution of sodium hydroxide with hydrochloric acid. One student obtains a smaller titer. Which procedure explains this? You see in this question, the sodium hydroxide is going to be in the conical flask and you're titrating it with HCl from the burette. Now, let's have a look at these possible reasons. What could give a small titer? Titer meaning volume used from the burette. The burette readings are taken from the top of the meniscus instead of the bottom. This wouldn't really make a difference because if this is your two readings, if you're reading from the top of the meniscus, the difference is still going to be the same. So A is ruled out. Whether it's from the top, whether it's from the bottom, that difference between them is going to be the same. The conical flask is rinsed with water before carrying out the titration. With this, because the conical flask, which is this over here, if it's rinsed out with water before carrying out the titration, that's only going to dilute slightly the sodium hydroxide, but the amount of moles in sodium hydroxide will be the same. So that means the titer, the volume of HCl, will be the same. It would not affect that. An air bubble is released from the jet of the burette during the titration. You see, if an air bubble is in the jet of the burette, it means that you're going to get a larger than actual value of your titer, a larger value, not a smaller. So this rules out C. Process of elimination, it will be D. But why will it be D? The pipette is rinsed with water before filling with NaOH. You see the pipette. If it's rinsed with water, that means you're going to have small amounts of water on the insides of the glassware. And so when you fill it with sodium hydroxide, 25 centimeters cubed, that's now going to be diluted. There's going to be less NaOH in that 25 centimeters cubed. Therefore, less HCl will be needed, giving you a smaller titer. Next question. Which statement gives the numerical value of Avogadro's constant? Which is this. The number of moles in 12 grams of carbon-12 is 1. There's only 1 mole in 12 grams of carbon-12, which is not, gives the numerical value. The number of moles, that answer would be 1. So it's not A. Let's look at C. Number of molecules in 16 grams of oxygen. Oxygen is O2. And the fact that it's molecules is more than one atom. That gives you 0.5 moles, which will be half of the Avogadro's number. So it's not C, it's not A. The number of atoms in 1 mole of chlorine molecules. You see, CO2, if you've got 1 mole of this, you'll end up having 2 moles of chlorine atoms. 2 moles will be double Avogadro's number. So D is ruled out. And why is it B? Because 20.05 divided by 40.1, which is the relative atomic mass of calcium, this gives you 0.5 moles. You see 1 mole of calcium gives you 2 moles of electrons because it gives you a Ca2 plus ion. So we only want 1 mole of electrons, and that's why having a half a mole will give you 1 mole of electrons. And 1 mole of electrons will have 6.02 times 10 to the 23 electrons that are lost. Answer is B. Mark scheme supports that. Let's move on. Calculation question. It says an element X is reacted with oxygen. Let's write a quick equation. And the formula it gives you is this. To balance, we'll put a 2 there and a 1.5 there. What is the identity of element X? So with oxygen, we've got 0.40 divided by 32. This gives you the moles of oxygen. Oxygen has a 1.5 to 2 ratio, or a 3 to 2 ratio. And so what we do, we divide this by 3 and multiply it by 2. This will give you the moles of element X. You've got the mass of element X and you'll have the mole of element X. And so what you do is M over N will give you the relative atomic mass. And we then compare that to these options. My calculator. .333 times 10 to the minus 3. And then let's do 0.80 divided by that answer. We've got here as 96. Okay. Yep. Aluminium is 27. No. Titanium is 47.9. Germanium is 72.6. Molybdenum is 90. MO 95.6. Sorry, 95.9. Yep. Answer would be D. And the mark scheme doesn't support that. What have we done wrong here? Oh, okay, I know what's happened. You see, by using whole numbers, we can turn this into a 3 and this into a 4, and that 2 there. So we divided by 3, but we should have multiplied it by 4. Let's try that. That's the mistake. And then 0.8 divided by that answer gives you 48. 48. And 48 is, 47.9 is titanium. So the answer will be B. And the mark scheme supports that. That makes sense. Next question. Phosphoric acid is a tri-basic acid. What is the mass of? That means all 3 H pluses are lost. H3PO4. What is the mass of calcium oxide hydroxide that completely neutralizes this volume and this concentration of phosphoric acid? You see, phosphoric acid reacts with calcium hydroxide. This gives you Ca3PO4. So we put a 3 there. And the PO4 will be 2. So put a big 2 there. Reacts in a 2 to 3 ratio. Some water given off. How much water is given off? It will be 3. Yep, 3. So let's work this out. Volume times concentration gives you number of moles of phosphoric acid. Phosphoric acid reacts in a 2 to 3 ratio. So what we do, 0.001 divided by 2 times by 3, and then we multiply it by the relative formula mass of calcium hydroxide. That will give you your answer. Calcium hydroxide is got the molar mass there. So 0.001 0. Oh, I've added an extra 0. Doing maths in your hands, in your mind, that's 0.1 and that's 0.1. That should give you 0.01. I'm rushing these today because it's the last day of term. I want to go home. 0.01. So let's just do that there. And that will give you, 1.11. C, that's correct. Which statement about elements in the D block of the period 4 of the periodic table is correct? Period 4 is from scandium to zinc. Chromium atoms have the electron configuration of this is correct. 1s2, 2s2, 2p6, 3s2, 3p6. This is actually correct. And let's have a look at why the others are not correct. Cu plus ions contain an incomplete 3D subshell. No, they don't. There's actually a 3D10 because the 4s1 electron is lost. This is full. Fe2 plus ions contain 3 unpaired electrons. You see, you got 3D6 and the 3D subshell is going to look like this. And you've got 6 electrons in there. And there's only 4 unpaired electrons. Scandium forms ions with different oxidation states. No, it doesn't. Scandium is 3 plus only. That's why it's not a transition element, but a D block element. The equation for combustion of heptane is shown in the following equation. Calculate the enthalpy change of combustion using these formation values. You see, in this question, you've got your reactants and you've got your products as given in the equation. Enthalpy change of formation is where one mole of a substance is formed from its elements. So what we're going to do, it's going to be, we're going against this arrow, as you can see, and with the second one, against, with. So it's going to be minus heptane enthalpy change of formation, and we, minus enthalpy change of formation of heptane will be minus that. Oxygen is 0, because forming O2 to give you O2, there's no energy change in that. So that's going to be 0. And then you add this times 7 and water times 4. Let's see what that gives. (3914 minus). Answer is A, and that's correct. With this question, I'm not even going to look at the answers. Let's look at this first. This is the Boltzmann distribution. Which statement for the Boltzmann distribution is correct at a higher temperature? You see, at a higher temperature, the peak of the Boltzmann distribution lowers and it shifts towards right. And because of this, you've got a greater proportion of molecules that have energy above the activation energy. So the peak increases in height. No, it doesn't. These two are ruled out. The peak decreases in height and it should be moves to the right. So it should be D. 7D, the mark scheme supports that. In this question, a graph is plotted of natural log K against 1 over T. And the gradient, if you look at the Arrhenius equation, you got natural log K. Your M is your EA over minus EA over RT. Your X is your 1 over T. And then you've got your Y-intercept, which is natural log of A. So your gradient is actually minus EA over RT. They want it in kilojoules per mole. So how do we do that? Minus 55000. Let's multiply that by, oops. It's not over, it's just over R. T we've got here. Just multiply that by 8.314 minus, to get rid of the minuses. That gives you in joules per mole, but we want it in kilojoules per mole, so we divide it by 1,000. So what we're doing there, minus EA over R multiplied by R. R is the gas constant you've used in the PV equals nRT from year 1. Getting a very different answer here. Oh, no, I'm not. 457.27. Didn't see the last one. Got a bit worried there, ladies and gentlemen. The calculator answer to this. Yeah, that gives you 457.27. Answer is D. And the mark scheme supports that. This is a KP question. In this equilibrium mixture, you've got the partial pressures of nitrogen, hydrogen, but they've not given for ammonia. You see ammonia partial pressure, what will it be? It'll be 25 minus 18.75 minus 25. Sorry, minus 2.5. That will give you the partial pressure of ammonia. Because all the partial pressures will add up to the total pressure of 25. $3.75. And what we do, we write down the expression to work out is products over reactants. We use curved brackets. So for ammonia, and square that. We raise the big numbers to the power, the partial pressure of nitrogen, multiplied by the partial pressure of hydrogen cubed. Where have these numbers come from? From here. Let's work this out in the calculator. 3.75 squared divided by, open bracket, N2 is 2.5 multiplied by, wait a minute, yep, 3.75, 18.75, and cube that. 8.53 times 10 to the minus 4. Right, made a mistake here. Let's go back. And what have we done wrong here? Products over reactants. The Kp expression is correct. The partial pressures seems to be correct. What have we done wrong here? Let's try one more time. Could be a calculator. 3.75. Let's square that. Let's divide that by nitrogen, which is 2.5, and then multiply that by, wait, no, it's not, 18.75 multiplied by 2.5 cubed. I think got the numbers mixed around. Yep, 0.048. I got these numbers, this one and this one muddled up. That's what a lapse of focus could cause, ladies and gentlemen. The answer is B, and the mark scheme supports that. The equation for the reaction of ICl and H2 is shown below. You've got the rate constant, which is this, and you've got the units. Now, the units, you see rate is mole per decimeter cubed per second. From there, to get that, you would need to divide by concentration squared. Where has that concentration squared come from? It's come from the rate equation, and that means the overall order of reaction is going to be 2, because you look at the powers. And so the answer will be C. Yep, that's correct. HCl and sodium hydroxide, they react in a 1-to-1 ratio. And if you look, all the sodium hydroxide gets used up, and you're going to end up with just 0.001 moles of HCl. And the volume of the total solution is going to be 20 centimeters cubed. Let's convert that to decimeters cubed. This will give you the H plus concentration, because this is of HCl. And we then plug that into the pH expression. And let's see what the calculator gives us. .30. And the mark scheme does not support that. What have we done here? D. Sodium hydroxide, HCl, that's correct. Sodium hydroxide, 10, and again 0.1. Yep, that's correct. Been trying to do the calculations in my head. So you see, when these react together, you're going to be left with only 0.02 times 0.1 gives you that. Let's divide that by 2. Yeah, that it will give you this. Divided by the total volume. Total volume. 20 and 10 added together will give you 30 centimeters cubed. That's the mistake we made. .48. Answer is D. Now we're talking 11D. This question here, the fact that this is an unbalanced equation, we need to balance it, but these type of equations, we always balance in terms of electrons. You see, iodine has a -1 oxidation number, and it goes to a +1 oxidation number here. Manganese goes from a +7 to a +4. Why is it a +7? Because oxygens are -2 each. And we balance accordingly. And we take into consideration the overall charge of the ion. So with iodine, it has lost 2 electrons, and manganese has gained 3 electrons. We need to balance these electrons. How will we balance? Put a big 3 there and a big 2 there. We cross multiply on these numbers. And then once we've established that, we then balance everything else using the normal balancing rules. 3 iodines on the left, 3 on the right, 2 manganese on the left, we do 2 on the right. And we now just look at the there's a little hack here. I can't think of another way to do this. But the hack is, look at the charges on the left-hand side. You got 3 minus plus 2 minus gives you 5 minus. And you've only got 3 minus here. That means the 2 minus must come from the OH. That means there must be a 2 in front of the OH. And 2-to-2 ratio is the same as 1-to-1. And the mark scheme supports that. Which statements are correct when the catalyst is added to a system in dynamic equilibrium? A catalyst speeds up the forward and the reverse by the same amount. That is correct. The concentrations of the reactants and products do not change. That is correct, because the equilibrium position does not shift. The value of Kc increases. No, it doesn't. Kc only affected by temperature. So 1 and 2 only. 13B is correct. Which statement for the group 2 elements is correct, is or are correct? The second ionization energy of magnesium is greater than the second ionization energy of calcium. Magnesium is here, calcium is immediately below it. Ionization energy decreases down the group. So magnesium would have a greater second ionization energy. That's correct. Strontium ion contains a total of 6 electrons in the s orbital. You see its electron configuration is going to have a 1s, 2, there'll be a 2s2, there'll be a 3s2, there'll be a 4s2, and then strontium's is 5s2, which these electrons are removed to give you the ion. There are 8 electrons here, not 6. And the last one, number 3, equation for the reaction of barium with water is as follows. It's supposed to give you the hydroxide, and the hydroxide is this, because barium is a 2+ ion and hydroxide ions are -1. So this is incorrect as well. 1 only. Yep, and the mark scheme supports that. And the last but not least question here. Which statement for this complex is correct? You see with cobalt, you've got 3 bidentate ligands. 3 bidentate ligands. We can draw them like this. Just showing you the shorthand version. When you've got 3 bidentate ligands, this gives rise to an optical isomer only. So it's going to be this. It has a 6-fold coordination number. Yes, it does. Does it have cis trans? No. Cis trans is only if you had, for example, a chloride ion where it could be there or it could be there. That's cis and trans. So it's going to be 2 and 3 only. The answer will be C. Ladies and gentlemen, the mark scheme supports that. That is the end of the multiple choice questions. And I look forward to seeing you tomorrow, same time at 8 p.m. Bye for now.